Hi, and welcome to this tutorial on how to use the RD8 platform to drive design decisions. Our topic today is transfer functions and nonlinear calculations. Imagine I am working on designing a coffee machine, much like the iconic one to the left here. At an early stage, I may have a principal sketch and want to calculate whether I can deliver on my functional requirement. Let's try it. I have created a new calculation and named it. Next, I will add my illustration. I will also add my requirement interval for brew pressure. This is useful for illustrating my result later. Down in the documentation section, I can also store any assumptions or explain idealizations and important notes for my calculation. Storing my rationales and thinking is usually very valuable. Same as having a good visualization of the problem I am trying to solve. The last thing I will do before starting to crack my problem is to apply tags to the calculation. This helps me navigate and create overview in my project, especially as the number of calculations and considerations grow. I could also just start without entering all of this data, but in this case, I am starting slow to finish fast. I will now create my illustration and take advantage of some of the automations in the RD8 platform. I am trying to calculate the brewing pressure inside the chamber of my machine. This is a classic force per area calculation, but with a twist here. My lever gears up the input force from the user via a torque balance. After that, the resulting force should then be projected in the direction of the piston travel. I have just quickly drawn in some help lines to clarify my illustration and calculation parameters. I will now draw in my lever lengths, the projection angle, and the diameter of my chamber. I will need these in a second. With my illustration complete, I have automatically gotten the calculation parameters created. I will fast forward through the nominal values, but notice a nice help here. For my geometric dimensions, I can simply set a tolerance grade and automatically get the corresponding tolerance for my dimension. This is a nice way to save time and ensure uniform tolerancing in my design. I am happy with my parameters and ready to move on. Notice the dot on my parameter entries. This is a helpful indicator showing that my parameter is not currently being used in my calculation. Good for keeping track of something I missed or maybe could remove. Let's use those parameters. I will write up my expression, converting input force through the system into the chamber. The RD8 platform uses real math notation to make it easy for you to see your calculation and name your parameters with subscripts or symbols. I will finish my function with a rough conversion to bar as the unit. With my function complete, something is wrong. I get a warning that I am using an undefined parameter. Good for finding my typos. I can easily correct it, and voila, all is in order. You can also see that my dot warnings on the parameters have now gone away, since I am using all of them in my function. It's pretty clear from my result graph that I am failing my requirement. However, a worst-case calculation method is a very conservative approach in this case. For this nonlinear function, I will switch to the Monte Carlo engine instead. I can run 1 million samples in seconds and get a plot of my result. Much better. I can also get an overview of parameter influence, regardless of whether it is a linear or a more advanced function. All done on this example. Remember that the RD8 platform is designed to work with you from basic sketching all the way to mature 3D CAD. As you can see, I could just as well have done this with a 3D model as the base, getting even more help from the built-in automations of my workflows. Thank you for watching. I hope you enjoyed this tutorial. If you are curious about how the RD8 platform can make a difference in your engineering design work, then get in touch. Go to rd8.ai. We look forward to exploring your design challenges.
Do you know the quality of your designs? We do.